Hey kids, we're back. Okay, you watched the YouTube video that some other science teacher made on physical versus chemical changes. All right, there's going to be 4 questions on your homework today about that. We talked about what happens when you heat something up. It undergoes a phase change. There are 2 questions on your homework about that. And now we're going to talk about conservation of mass. Okay, conservation of mass applies in physical changes, in chemical changes, but not in nuclear changes. Okay, remember nuclear changes said the equation E equals mc squared, Einstein's famous equation. That applies in the case of a chemical change. Or sorry, a nuclear change. Okay, in chemical changes, mass is conserved. All you're doing is changing it from one substance to another. All right, if I burn diesel fuel or gasoline in my car, right, the diesel fuel is going to react with oxygen in the air, and you're going to produce carbon dioxide and water. Okay, something different than what you started with. Okay, 2 new substances are made from 2 original substances. All right, let's talk first about this heating curve one more time. Okay, as I increase the temperature, okay, of a solid, right, over time, I'm adding heat to it. Right, my solid is going to warm up. It's going to reach the melting point and it's begin to melt. During the melting phase, okay, the melting time, some will exist as a solid, some as a liquid. Okay, then when you get all liquid, then the temperature will continue increasing. Okay, this whole time, we're actually adding heat the whole time. Okay, so maybe we should write heat down here also. All right, we're adding heat at a constant rate. Say that. Okay, we're adding heat to this thing at a constant rate. Heats it up, begins to melt. When it's all melted, then we heat up the liquid. Then you're going to be the liquid to gas, right? This is called vaporization, okay, or evaporation. All right. As we go through there, the temperature remains constant. Okay, we're still adding heat. Time is still going by. Okay, once it's all a gas, we can heat up the gas as we add more heat. Okay, but no matter where you're at on here, the mass is always the same. Whether you're here or here or here or here or here, right? Your mass is always the same because these are just physical changes. Now, if I boil water on a stove, it might seem like my pot of water is losing mass, but that's because the water vapor is spreading out through the atmosphere, okay, in the room. But you're not actually losing mass, okay? Physical changes do not lose mass or gain mass. Chemical changes do not lose mass or gain mass. If something goes into a gas phase, it can be harder to measure the mass of that, right? It's easy. We can take solids and liquids and put them on a scale, right? We can measure the mass easily that way. Gas is a little harder, but it's still there. All right. Now let's talk about chemical reactions and the conservation of mass. Now you will have a final question or 2 based on this right here, so do pay attention. And there's a glare. I wonder if I can do anything about that. No, it didn't really help. Stressing. All right, so turn off the lights in the room and get rid of some of the glare maybe, but it's not great. All right. Let's see. So let's just move this computer over here maybe, and I'll go the other way. That's gross glare, isn't it? All right, so we still have some glare, but at least I think it's easy to see now. I move the computer, put it up on a chair on top of a desk. Anyway, reactants are on this side of the arrow. Okay, this arrow right here separates our reactants from our products. Okay, reactants are what you start with in a chemical reaction. Products are what you produce. Okay. So in this case, you've got X makes Y plus Z. Okay, so if I take something and I break it apart, right, through a chemical reaction, it's going to produce 2 different things. Okay, so this is thing 1, thing 2, thing 3, right? Different things. Whenever you do a chemical reaction, the mass of your reactants is equal to the mass of your products. That's the law of conservation of mass. Okay, it applies in chemical reactions. It applies in physical changes. All right, not nuclear reactions. Okay, so mass of products is equal to mass of reactants, left side of the arrow, is equal to mass of the products. Okay, so if I've got 60 grams of reactant, okay, and it breaks down into 2 products, if I weigh this product and I find it's 20 grams, then I can calculate the amount of Z that should be produced, right? So I have 60 here, 20 there. This side has to equal that side. So what's my answer? Question mark would be 40 grams. We'll write it in green. Okay. Yep. All right. Okay, so I went and grabbed an eraser and took out my question mark, right? Now let's do another one. All right. So 60 grams of reactants, 20 grams of that. We have to have 40 grams of this in order to make 60 on this side and 60 on that side. All right, let's erase this right here. Do a little something different. What if we had, say, 60 grams of Z? All right, and let's say we had 60 grams of Y. Okay, let's say we made the same amount of each. Okay, grams. All right, if we want to know how much X we started with, all we have to do is add these two guys together, right? Because this side has to equal that side. Okay, so 60 plus 60 makes 120. All right, pretty simple. There are some test questions like this on the EOC. I'm going to give you about 4 questions like this in your homework today. All right, all you got to do is figure out, okay, read the problem statement, write so many grams of X, so many grams of Y, so many grams of Z. Okay, one of these you won't know, but all you got to do is add or subtract, right? Okay, let's do another one. Erase that. Oh, my green is not erasing well today. All right, let's just go back to black. Okay, let's say we have not a lot else we can do with just 3 things. Okay, let's say we have 200 grams of this, right? And let's say you got 50 grams of Z. Okay, how many grams of Y would I have? Okay, well, this side has to equal that side, so it's going to be 150, right? Because 150 plus 50 will give me 200, so this is 150 grams, okay, of Y. 50 grams of Z, 200 grams of X, okay? It's pretty simple. Now, you might have, right, we could change this around. We could say, right, we could do X plus Y equals, or sorry, let's see, makes Z. Okay? And that's how you write a chemical reaction. Okay, we'd write like, sodium bicarbonate, right, baking soda, plus vinegar, which is acetic acid, okay, makes something else, right? It actually makes 2 things. All right, but anyway, you were just write down the things that you're dealing with. So now I've got 2 reactants, right? So I'm going to have 2 things over here. I'm going to have Y, I'm going to have X. I'm going to have one thing over here, Z, right? So let's say we make 150 grams of Z. Let's just make our math simple. Let's make Y 80 grams. Okay, how many grams of X did we use? Well, it would have to be 70, because mass has to be conserved. This side has to equal that side. Okay, this would be 70 grams. All right, so I'm just going to do that. It's real simple. All right, I'm going to make 4 things up here now and do a problem with that. Okay? Okay, so I changed our problem. Right, now we've got reactants and products. Okay, this time I used A and B. They're just generic, for something. Could be water and, I don't know, something else. Could be, gasoline and oxygen, carbon dioxide and water. All right, doesn't matter. These are just generics, right? A, B, C, and D represent 4 different substances. Okay? All right, mass reactants equals mass of products. Now, let's say we had 100 grams of A, an unknown amount of B was used. We produced 50 grams of C and 80 grams of D. Okay? How many grams of B were used? All right, that's easy. 80 plus 50 would be 130. There's 100 over here. That means I need 30 more grams. So this had to be 30 grams. Okay, all it is simple addition and subtraction. All right, that's it. It's not complicated. Okay, let's do one more. Same 4 things. All right, we're going to change up our values here. I don't know. Let's do something we can't figure out. Okay, we'll make this 100 grams again. We'll make this 50 grams. All right, I don't know if you can read that. Okay, that's supposed to be a 50. Okay. Now let's say whoa, what just happened here?